This video tutorial will teach you how to use the ramping module of Test Universe. This module determines limiting values of protection functions like the overvoltage or under-frequency pickup by generating ramps through the CMC test set. Ramping is able to perform an unlimited number of measurements, which are automatically assessed according to user-defined tolerance parameters. In this video, we will be testing the pickup value of our relay's emergency overcurrent protection function. Going back to the OCC file, we insert a new group called pickup values, which will contain the ramping module. To make the procedure easy to understand, we will support our explanation with the following figure, which includes all the parameters required to perform the test. The relay's pickup value has been set to 1.8 amps and is signified by the blue line. According to the relay's manual, the pickup value has a tolerance of 3%, determining both upper and lower limits that are represented by green lines in the figure. The goal of this test is to check that the pickup value is contained within the tolerance band. Now it is time to define the start and end values of the ramp. This way, you are free to choose any value as long as you ensure that the ramp will cross the entire tolerance band. However, just to give you an easy rule to follow, our advice is to start at 0.8 times and end at 1.2 times the nominal value. The calculated values are 1.44 amps and 2.16 amps. That said, we can proceed to complete the fields with these values. But before going any further, we have to check our test object and local hardware configurations according to OMICRON's Ohm's law. Regarding the test object, there is no need to make any change. For this specific test, we just activate 3 currents and the start contact in the local hardware configuration. No binary outputs are required. Like the other modules, the ramping module comprises several views. At first, in the ramping's test view, you can select the shape of the ramp by adding states and setting the individual ramp parameters. Like the other test modules, you can define the set mode. 2 functions of any signal combination can be ramped simultaneously up to 40 ramp states. In this example, we will use 2 states to ramp a combination of 3-phase current magnitudes in direct mode. The first state will be used to ramp up and the second state to ramp down. According to our previous figure, the starting point of the ramp will be 1.44 amps, while the end point is 2.16 amps. For the second ramp, we just enter the same values. The steps are defined by the time and delta magnitudes. The amplitude of delta is a compromise between accuracy and test time. The bigger it is, the less accurate and shorter the test time. If you choose a value bigger than the tolerance band, the resulting measurement will be of no use. As a reference, we recommend that you take the tolerance divided by 4 as delta magnitude. That is, 3% of 1.8 amps divided by 4, which makes 14 milliamps. The time is the period between 2 ramp steps. This duration must be longer than the operating time of the relay. Since the pickup is estimated by the relay's manual to be 30 milliseconds, the step time has to be greater than this value. Therefore, 100 milliseconds will suffice. We apply the same settings for the second ramp. Out of these values, the number of steps and the total amount of time for the test is calculated automatically. The total number of steps indicated here is the maximum number assuming that the ramp is not stopped by a trigger condition, and as a result, it reaches the end value. The total time represents the number of steps multiplied by the step time. The stop condition displays the ramp state's trigger condition. This condition is set in the detail view. The detail view window has three separate tabs. In the first tab, called Analog Outputs, you can set the static values of the non-ramped analog CMC outputs. This is why the ramped values are grayed out, as seen in the fields that contain the three current magnitudes. In this case, only the phase and frequency components can be modified. In the second tab, you can activate or deactivate the CMC binary outputs. However, these outputs are disabled on the hardware configuration since there is no need to apply them in this example. Finally, the third tab will set individual stop conditions to terminate the state before it reaches its end value. The default setting is None, that is, no trigger will stop the ramp state. It runs from 1.44 amps to 2.16 amps. The key pressed option enables you to manually trigger the ramp state termination during the test. When the ramp starts, a dialog box will pop up and wait until you press continue. The binary trigger can be any single binary input of the CMC or a logical combination or multiple binary inputs. The logic functions and/or are available for that purpose. In the binary trigger condition box, you need to specify the binary inputs you want to use. In our example, the first state must stop when the start signal switches to 1, while the second state must stop when the start signal goes back to 0. Note that the detail view needs to be configured for each state. Toggle from one state to the other by clicking the arrows from the ramp navigation toolbar or directly selecting the specific state. Once the ramp parameters are set, it is possible to specify measurement conditions for automatic assessments. Also, ramp calculated assessments are available. Toggle from one to the other in the View tab. An unlimited number of measurements can be performed. If we have a look at the ramp assessments table, we first need to enter the name of the measurement. We strongly recommend that you use the name that best reflects what is actually measured. For example, pickup and drop-off. The ramp column shows the ramp state in which the measurement is performed. The pickup will take place in state 1, while the drop-off will take place in state 2. The condition column reflects the condition to start the measurement. We will measure the pickup value when the start contact switches to 1 and the drop-off value when switching to 0. The nominal value is the expected value, 1.8 amps for the pickup. According to the relay's manual, the drop-off value is around 0.95 times the pickup, which makes 1.71 amps. The deviation contains the allowed tolerance values. As explained before, the tolerance is 3% in both directions, positive and negative. 3% of 1.8 amps makes 54 milliamps. We can keep the same value for the drop-off deviation. The rest of the columns display the actual values after the test is performed. In the Calculated Assessments table, we can define calculations of signal relations, for example, the pickup to drop-off ratio. The nominal value will be 0.95 according to the relay's manual. Normally, you do not find any tolerance of this ratio in the manual, so we can keep the default value of 5%. Now, the test is ready to be performed.